Oceans cover approximately 71% of Earth's surface and play a fundamental role in regulating the planet's climate. Through their ability to absorb and store heat, carbon dioxide, and redistribute energy via ocean currents, the oceans act as a buffer against extreme climate variations. This article explores the mechanisms by which oceans influence climate, their interaction with the atmosphere, and the implications of oceanic changes on global warming and climate stability. The Earth's climate system is a delicate balance of energy exchanges between the atmosphere, land, and oceans. The oceans are a critical component of this system, acting as a climate engine that stabilizes temperature, drives weather patterns, and absorbs carbon emissions. Understanding the ocean's role in regulating climate is crucial for predicting the impacts of human-induced climate change. Oceans absorb about 93% of the excess heat generated by human activities, primarily from greenhouse gas emissions. This capacity to store heat arises from water's high specific heat, which allows it to absorb large amounts of energy without significant temperature changes. Ocean currents, both surface and deep, play a vital role in redistributing heat across the globe. Driven by wind patterns, surface currents, such as the Gulf Stream, transport warm water from the equator toward the poles, moderating temperatures in regions like North America and Europe. Known as the global conveyor belt, this system of deep ocean currents is driven by differences in water density, which depend on temperature and salinity. It circulates heat, nutrients, and carbon dioxide throughout the oceans. Without these currents, regional climates would be far more extreme. The oceans absorb roughly 25% of the CO2 emitted into the atmosphere annually. This occurs through two primary mechanisms. CO2 dissolves into surface waters and is transported to deeper layers by ocean currents. Phytoplankton at the ocean's surface absorbs CO2 during photosynthesis. When these organisms die, they sink, effectively sequestering carbon in the deep ocean. While oceans mitigate atmospheric CO2, this absorption leads to ocean acidification, which reduces pH levels and affects marine ecosystems, particularly organisms with calcium carbonate shells like corals and shellfish. Oceans drive the global water cycle by providing moisture for the atmosphere through evaporation. This moisture fuels precipitation, influencing weather patterns and regional climates. Oceans influence climate variability through periodic changes in sea surface temperatures. Global warming is causing ocean temperatures to rise, with consequences including warmer waters that stress coral reefs, leading to bleaching and widespread ecosystem damage. Rising temperatures cause seawater to expand, contributing to sea level rise. Warmer oceans accelerate the melting of polar ice caps and glacier, which reduces the Earth's albedo. Darker ocean surfaces absorb more heat, creating a positive feedback loop that amplifies warming. Climate change may weaken or disrupt critical ocean circulation systems. The central role of oceans in climate regulation underscores the urgency of protecting marine ecosystems and mitigating climate change. Reducing emissions, protecting coastal ecosystems, and promoting sustainable fishing are key strategies. The oceans are a cornerstone of Earth's climate system, providing critical services such as heat storage, carbon absorption, and energy redistribution. However, their capacity to buffer the impacts of human activity is not infinite.